Motion sickness arises from conflicting sensory information received by the brain. The primary conflict is between visual input and inner ear perception of movement. If the eyes perceive a static environment, the brain expects a sensation of stillness. However, the inner ears may detect movement, signaling a different reality to the brain. This sensory mismatch leads to confusion in the brain, triggering the symptoms of motion sickness. The inner ear houses structures crucial for sensing motion and maintaining balance. These structures detect changes in movement, such as acceleration and deceleration. They also register rotational movements, like turns. When in motion, these structures generate signals based on the experienced movement. These signals are then transmitted to the brain for processing. This allows the brain to understand the body's motion and maintain equilibrium. A conflict between visual input and balance signals can indicate toxin ingestion from an evolutionary perspective. The brain interprets this sensory mismatch as a potential sign of poisoning. This interpretation triggers a nausea response as a protective mechanism. Nausea is induced to expel the perceived threat, which could be a harmful substance. This expulsion is a survival strategy to minimize the negative effects of potential toxins. Motion sickness can be triggered by conflicting sensory inputs. Reading in a moving car can cause motion sickness due to visual focus on a stationary object conflicting with the sensed movement. The eyes focus on the static page while the inner ears detect the car's motion. Experiencing motion in video games while physically stationary can also induce motion sickness. Motion sickness can be reduced by focusing on a distant, stable point. Focusing on a fixed point helps align visual input with the inner ear's motion sense. This alignment minimizes sensory conflict, a primary cause of motion sickness. Ginger chews and acupressure bands can also help calm the brain's response to motion.